soon. So statistics, the collection and analysis of data. We are going to focus on analyzing it, okay? What does it tell us? Aims to interpret what the data is trying to tell us. It aims for it, right? Interpreting is kind of like hash it out, like break it down, see what it's trying to tell us, okay? Some of the concepts that you're going to need already, you're going to have seen them. Hopefully you saw them before, is the MCTs, the measures of central tendency. There's your mean, your median, and your mode. Does that mean anything to you? Mean, median, mode? Average, right? Dispersion talks about the range. So we're talking about how widespread is our data. How does it deviate from the mean? Okay. Data is always at the center. Okay. So our data is going to be height, scores of exams, tests, whatever, IQ scores, number of items that were collected per day or sold per day, and so forth. So it could be anything. Okay. This is probably new right here. Standard deviation. I don't think you will have heard of standard deviation before. You can put this symbol there. It's like a 0 with it's a sigma. It's a lowercase sigma. See, I'm full of surprises, right? 6, 7. Measures how spread out the data is. I just remember now that sigma is a thing. Tells us how much data deviates from the mean. Okay, so it tells us how spread out it is and how much it deviates from the mean. Deviating means wanders off or moves away from our average. Then we're also going to talk about visually representing our data using one of these 4. I'll tell you more about that later. But normal distribution right here, just a review for you. If you have a ruler, I'm going to use a ruler for this. So we usually have our x-axis, and if data is normally distributed, the mean, the average, is at the center. And so most of our data, if we collect it, if we were to stack our data that we're collecting, just make a bunch of dots here. Like if every data point represented a dot, it would land somewhere in here. As you move away from the mean, so let's say we're talking about average height, right? You would find that in Canada, we would somehow figure out that most people are somewhere around that average. And then as you move away from that, some people are shorter, but you don't find that many people. Obviously, you'd have to break this down by age. You couldn't like include babies or whatever, right? You'd have to say like at 20 years old, this is the average height. If you move to the taller, right, to the taller side, again, the number of people being there will be dwindling as well. And so this is what I want you to have on there. Go to where the mean is, make a dot like way up top here, and then we're going to spread out like this. It looks like a bell curve. There's a bell curve. Do you remember when they said we need to flatten the curve during COVID? Does that ring a bell? What they wanted is they didn't want all cases to bunch up and then overwhelm the healthcare system. They didn't want this to happen. They wanted to flatten the curve, so they wanted to spread out the cases. That's what they were talking about. It comes back to this, okay? So it looks like a bell curve or like a sombrero. Some people like sombreros or other than belts. That's what normal distribution is all about, okay? So we're going to talk about that. It turns out that a lot of things in life are normally distributed, especially when it comes to human attributes, okay? Let's keep going. So this is just an overview. Let's start with our mean, median, and mode. So sorry, I'm going to talk a lot today, so if that bothers you, I'm going to bother you a lot today. So mean, median, mode. Of course, I'm going to highlight that just so I know that I talked about it. Altogether, collectively, they're called MCTs, okay? They're measures of central tendency. They try to find the middle. Bless you. It's the number around which the data tends to cluster. The most common one is the arithmetic mean, usually called the average as well. The arithmetic mean is the most common. It's called the average in everyday language. So mean is the X with the bar on top is the symbol, or mu. Mu, almost like meow. The arithmetic mean is denoted by the symbol, right there it is again, X bar. It is found by adding up all the values in the data and then dividing the sum by the number of values in the set. Make sure you include units, please. Okay. So this is the formula, the official formula. So X bar is capital sigma, right? Sigma is the sum. Add everything up. Then you divide it by n. Okay? So sum of all values, sum of all values divided by the number of values. The median of a set of numbers is the middle value. It is most easily found when the numbers are listed in ascending or descending order. So I would say it's the middle value. It's best to do ascending or descending. And I'm going to switch colors here. Half of the values are below, and half of the values of the median will be above. It's finding the middle. If there's an even number of values in the data set, the median is the average or the mean of the two middle numbers. Make sure you include units as well. I'm going to give you some examples here. If you have 2, 3, 5, 11, 16, you've got odd number, okay? In this case, your median is this value right here. No big deal there. But let's do another example. It's 2, 3, 5, 11, 16, 21. That used to be a thing too, right? So in this case, the median, because it's an even number of values, like you cannot just pick one value and have the same number of values below or above, right? So you're kind of stuck. So what you need to do is you need to add these two and then divide it by 2. So 5 plus 11 is 16. 16 divided by 2 is 8. So 8 units is our median in this case. So 8 would be right here. It would make it so that there's half of the values below, half of them above. Mode is the number that occurs most often in the list. Okay? Make sure you include units again. I'm saying this because a lot of students think that, don't need to, it's all good. So you could have no mode, one mode, or a number of modes. Okay? So, no mode would be this. An example, 3, 3, 4, 4, 5, 5, 11, 11. Okay? There's every single number appears the same number of times. There's not one single one, right? Or there isn't even two numbers that appear more than all the others. They all appear the same number of times. So, no mode. Common error is to say that the mode is 0. That is a mistake, because then you're saying 0 is the most common value in the set. So please don't say 0. One mode would be, I'm using the same set again, folks. I'm just going to make 5 show up one extra time. Everything shows up 2 times except for 5. So, right, so your mode is 5 units. You only have one single mode there. A number of modes, I'm going to go -3, 0, 1, 1, 1, 7, 12, 13, 13, 13, 6, 7. You look at your set and you see that you've got 3 1s and 3 13s. So these are the most common ones. They are tied, but and all the other ones only appear once. So in this case, your mode is 1. Sorry, it's not supposed to be a comma yet. Your mode is 1, comma 13 units. Although the mode is referred to a measure of central tendency, it does not necessarily lie towards the center of the list. So sometimes it's not a very good measure of central tendency. The mode is used in various situations where mean and median would kind of not be applicable. For example, a store owner would use the mode to find out the size of t-shirts that is most popular and use that information to decide how many t-shirts of each size to order in the future. Mean and median wouldn't help the store owner in this decision. Okay. Range. This is not an MCT. I think I need to add a formula here, yeah. Calculated by subtracting the smallest from the largest. It is the measure of dispersion, which tells us how spread out the data points are. So to find the range, you take the max, the highest number, minus your min. This is not the same as the range of a function. Booklet. Not the same as the range of a function. Okay. All right. Outliers. The name kind of says it all. They're lying outside, right? Values that are significantly different from the general trend. Outliers cause the mean to either increase if you have an upper outlier or decrease if you have a lower outlier. Outliers also affect the range of your data. The best visual that I can give you is if you've got a bunch of points that are close together, you could even have them stacked, but then all of a sudden you have an outlier, okay, that would be clearly visible on the number line. It varies significantly from the rest, okay? And now I need to talk about page 3. I apologize for those graphs. They're not the greatest. I tried to use my mouse to make the bell curve. This is new, should be new to you. If not, then I would like to talk to you. Where did you hear about this before? But standard deviation, okay? It's a lowercase sigma, lowercase, okay? Sometimes I refer to it as SD, or I use that sigma, or I actually write out standard deviation. What does it do? It measures the dispersion or variation within data points. Come again, Mr. Erickson, what's that? Put simply, the standard deviation is the average distance from the mean of all the points in the set. This can be calculated and will have the same units as the data set. So there are two cases that we're going to consider specifically. One case where you have a lower standard deviation. A lower standard deviation tells us all of these things. That the range will be low as well. That the data points are going to be, in general, closer to the mean. The data is clustered around the mean. These are basically saying the same thing. I just want to give you different ways to express yourself, okay? It also means that data is consistent, mostly closer to the mean, few or no outliers, and graphically, visually, the graph will show a steeper curve, okay? So think about it. The min and the max are fairly close to your mean, and you've got most values are kind of like, think of this as a number line, and we're just filling this up with numbers that we're collecting. So most of your points are kind of grouped up here, clustered around the mean. Okay, so I will actually ask you to grab a pen or a marker. We usually kind of draw our mean line like this. This is where the mean is at, and we look at how close is everything to that mean. The standard deviation actually takes every single point and figures out how close it is to the mean, and then finds the average distance of all those distances. So if you have a low standard deviation, it tells you, oh, most data points are closer to the mean, okay? Remember that. And you might want to come back to this, add this to your study sheet, right? Some students just flat out just add this to their study sheet because it's too much for them to take at the, right now. A higher standard deviation indicates the exact opposite. The range will be greater. Remember, range is the difference between the max and the min. And look at the graph. Compared to our max and min here, they're closer. Well, all of a sudden here, the highest and the lowest values are further apart. Okay, so if you have a higher standard deviation, that tells you that the range will be greater. The data points are more spread out. Data is scattered further from the mean, less consistent, and the graph will have a flatter curve. Okay, so here's your mean. Okay, and so we have things are spread out. So spread out, and I'm just going to go arrows. It's kind of like flatter outside. Okay, so for an athlete, for example, if you're into sports, you would want an athlete that is, let's say you keep track of free throws, right, as basketball, right? And you would want to, like, if you keep track of free throws during a game, you would want a player that kind of stays closer to that average that they're, because that means that that player is consistently performing about the same. Maybe a little bit more, maybe a bit less, but it's not like this player. You've got like games where it's just terrible, right? Like way out here. Games that are really great, and then everything in between. And that's harder for a coach to work with, right? So you're looking for consistency. So when it comes to sports, that's what you want, okay? When it comes to Amazon reviews, right? Would you want to purchase an item that has reviews that are all over the place? Like 0, 1 star, 1 star, 5 stars, like it's all over the place. It's like really spread out. Or would you rather go with a product that maybe doesn't have the highest reviews? Maybe it has 4 stars, but most people are staying around the 4 star. You're like, okay, it's probably consistent, right? There's some consistency there. So this can be applied to a lot of scenarios. Remember this, okay? This is study sheet entry perhaps for a lot of you. Now let's use our calculator, use the features that our calculator offers here. Because I know that in younger years, you're probably like, oh, find the mean, 6 values, have fun, right? But what if you have like 30, 40 values, like lots of values? Then it's very hard to go this, plus this, plus this, plus this, like, oops, did I add this one already, right? And it just gets messy. And that's not how data would be computed in a big scale. So here's where the calculator comes to your rescue. These are the steps. We're going to enter our data into L1. By now, you should know where to find that, but I remind you, we don't have L2 here, guys, only L1, okay, for now. Sort your data. So we're going to sort it in ascending order. Third, we're going to calculate the mean, standard deviation, and the median using one variable statistics. I'll show you this in a bit, okay? If you're done everything, you should see something like this on your screen. And this is write this down here, please. This right here, the X with the bar, that is your mean. I'm going to highlight the most important ones that you need to copy, okay? You've got your mean. You've got you see the lowercase sigma right here next to the X. This one right here is what we call a standard deviation. And let's give this one a different color here. N, what do you think N is going to tell us? How many elements, how many data points we're considering? Number of values. And if you're wondering, what's that arrow here? What's that arrow? That means that on your screen, you're going to have to go all the way down, and then it flips to this part of your screen. So there's like a two-part, 2 pages basically to the results. So this is another important one right here. I'm going to use a different color yet. This one right here is the lowest value that the data set has, min X, and this is the greatest value that it has. Okay, so this is the lowest value, and this is the greatest value. No surprises there. And median, right there. This thing calculates the median for you. You're welcome. So you basically know the mean, the standard deviation, the median. What is not in here? Which one of the MCTs is not in here? It's the mode. Mode is on you to find it, but I'll show you it's not too hard to find it at all. So if you find the range, you subtract max X and min X using the calculator. So example, in this case, the range would be, what's the max here? The max is 9 minus, what is the min? Negative 12, right? So it ends up being 9 plus 12, which is 21 units. And if this had been degrees Celsius, you would say there's a 21 degrees Celsius difference between the cities, or sorry, between the highest and the lowest temperature. Determine the mode by looking at L1, which is now sorted. So we're going to do that using, that's why I sorted in ascending order to find the mode. So these are the steps here to go through. Let's put this into practice. I'm going to ask you we're going to compare Toronto and Winnipeg. Let's first do Toronto, okay? So, or if you are from Toronto, Tirana, right? I don't know if you're familiar with it, but that's apparently how they pronounce Toronto. All right. Sorry to hurt your feelings if you're from Toronto. Just trying to have a bit of fun here. You can make fun of our cold winter. You go for it. Okay, so let's go to L1 and enter the temperatures for Toronto. So, okay, 5, 5, 8, 9. No negatives. Lucky Toronto, right? This is in April. So this is the month of April. I'm quickly going to check, okay? It says here on my very last entry that I'm supposed to be on my 12th entry. I can see it looking at my calculator. So 2, 4, 6, 8, 10, 12. We're good. Now we're going to go stat. Don't go calculate, okay? You're going to go sort. I like to sort this. So you go select that second option. It takes sort ascending order. You got to feed it L1. So you got to go second 1. You can close brackets, it doesn't hurt. Hit enter. It says done. It means that if you go back to L1 now, it's all going to be sorted for us. So let's go check it out. Stat, edit, and there it is. Sorted in ascending order. So, let's figure out the mean, median, and mode. Mean. Let's do the mode before we proceed. What is the mode here? I look and I'm seeing 3 5s. So 5 is so far a mode. And I see 3 9s. So 5 and 9 are the modes here. Got it? Okay. So 5 degrees Celsius and 9 degrees Celsius. For the other, we have to figure out, it didn't ask for standard deviation, but I'm going to do that anyway. So put a little lowercase sigma here for standard deviation. We're going to go ahead and find that as well. And then we're going to do the range. So now that we have the mode, I go stat again. You're with me, right? Stat, calculate, and we're going to use one variable stats every time. We'll never use 2 variable stats in this course. So 1 variable stats, hit enter. You got to feed it L1. So second 1. So you're saying 1 variable stats, please do your thing with L1. Hit enter, and then you get this screen. So copy everything down. My average is 6.83 degrees Celsius. My median, you have to use your arrows a little bit. So I'm going to go arrow down, and there it shows up for me. It's 7.5 right there. So just keep arrow down until you see median. So median is 7.5 degrees Celsius. And let's find our standard deviation. Standard deviation is this one right here, 3.21. Everything has Celsius, Celsius, Celsius. Okay. What is the range? The range is max minus min. So I will figure that out. You go to your calculator. My max is 12 here. And my min is 0. So 12 minus 0. So that's just 12 degrees Celsius. I want you to do the same thing with Winnipeg. We're going to figure out the mean, the median, the mode, We're going to figure out the standard deviation and the range. Question. We were talking April, so if you haven't been here in April, it's okay. What do you think my standard deviation is going to be? Is it going to be bigger or smaller than Toronto? Wait a minute, what's standard deviation again, Mr. Dirksen? How spread out your data is. If it's a small number, it's going to be not as spread out. It's going to be more consistent. If it's a big number, it's going to be spread out. Do the math and see what you get. I just want you to think of it. Okay, so I'm just going to write down the numbers you were supposed to have gotten. So it's 0.5, sorry. 0.5 degrees Celsius is the average, no surprise. Median, 1.5 degrees Celsius. The mode, there's only one mode, which is 6 degrees Celsius. The range is 9 minus negative 12. That's basically 9 plus 12. There's a 21 degree separation, right? So there's a big gap between the highest and the lowest. Yeah. What's that over there? Range. Thank you. I have it differently on my key here, and I'm not paying attention, obviously. Standard deviation is 5.77. Right? 5.77? Okay. So look at this specifically, right? So lower standard deviation, lower range. Higher standard deviation, meaning it's more spread out, higher range, right? So keep that in mind. Now, I want you to keep these numbers in your L1. We're going to do a number line. It's actually fun because the calculator makes it a lot easier for us. So line plots, from now on, I need you to know what they are, okay? Some hints here, use the min and the max on your calculator to help you determine the scale. Add labels and have units on there. Place data points on the line. Stack if there are multiple entries. And I'm going to use a different color because this is the one that students forget all the time. Label your MCTs on that number line. So because we have Winnipeg in our calculator already, we're going to do this first. Okay, so give me one moment here. I'm going to make this one equal to L1. So I'm going to store my Winnipeg values in there, and I'm going to do Toronto real quick. Sorry guys, I have to redo this. 6, 1, 3, 0, negative 1. Okay. Make sure, guys, especially for this one, make sure you sort it. Okay. For number lines, sorting is key. So I have it sorted. That's Winnipeg. I'm going to start with Winnipeg. And notice that in order to figure out your scale, because I was nice here, I started us off. I kind of wanted the same starting point. What is the highest temperature that Winnipeg has? I'm going to go on my 9 is the highest. And negative 12 is the lowest. So you kind of want to make sure you account for that. So what scale can I use? I'm going to try a few things here. I'm going to say, I'm going to go up by 3, let's say. So it's be negative 13, negative 10, negative 7, negative 4, negative 1, 2, 5, 8, 11, 14. Mr. Erickson, could I have gone up by 5s? Yes, you can, but you don't want to go up by too much at a time because you want to make sure you're able to fit your point in there, okay? So you grab your calculator. You have it right next to your sheet right here. And guys, this is just putting dots down. Negative 12 is somewhere over here. Negative 7 is actually right here. Negative 5 is somewhere here. Negative 1 is right on this line. 0 is right there. Because I'm imagining that 1 is right here. Okay. And then 1 is right there. 2 is right there. 3, 4, 6. There's another 6. You got to stack them. 9. Oh, sorry, that's not correct. I put the 9 should be right here. And that's it. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 data points there. And that is it. So you go temperatures in degrees Celsius. We're going to say that this is our mode. Right? Just make an arrow that points to it. What was our median? Is it 1.5? So it's somewhere there. Somewhere in there is our median. And our average was 0.5, right? So it's somewhere in here. You can just go X bar. Okay, so have those labeled. And that's it. That's a number line right there. Technically, we're supposed to have arrowheads on both ends of that number line that we've created. And then we do the same thing for Toronto. I'm going to use the same scale in this case because I like to compare these two. If it didn't compare, I wouldn't really care. So I'm going to copy the exact same numbers. I already have these points in my calculator. And I start at 0. Look at that, Toronto. You get as low as 0. Right? 3, 5, 5. This one is easy for me to catch. Like if I don't see 3 stacked, for example, that would be easy to catch in this case. 7, 8. There's 3 9s, 10, and 12. And then you just go temp, degrees Celsius. We've got 2 modes here, so I'm just going to go mode like that. What was the median for this one? Median is 7.5. So we'll just make an arrow going there, median. Oh, sorry, I'm on the wrong one. Median is right about there. And the average was 6.83. Right about there is our average. 6.83. Close enough is good enough. Question. Can you see visually that Winnipeg is more spread out? Right? And you can see that Toronto is clustered. So it validates what I was just telling you. You will see this time and time. So especially when you compare 2 cities or 2 different companies, right? You will see that. You will see that correlation. I will just make a note. Please don't do this normally, but in this case, it would go like a bit more like this. In this case, what's my bell curve going to be like? It's going to be more like this, right? Steep, flat. That's all I'm going to say there. Maybe I will also state the range and the standard deviation for both of these. There's nothing wrong with you adding it. In fact, I would say if you want to add that every time, absolutely more info is better. And the most challenging part is actually describe the data using statistical terms. That's going to be for you probably the most challenging. But that's why I gave you that little page, right, with the standard deviation. What does it tell us? What does it tell us about the graph? You can use that, okay? And then you'll practice this. Describe the data set. So you can, from Toronto's perspective, so you can choose which one you want to focus on. When it comes to the mean, let's talk about the mean, right? A greater mean temperature indicates overall warmer temperatures over Winnipeg. So a greater mean just says that overall you're expecting it to be warmer no matter what. When it comes to the standard deviation, so if you want to talk about the range and the standard deviation, if you want to combine those and talk about them, the range and standard deviation are lower which indicates that data is clustered around the mean. This tells us that most days will have a temperature that is closer to the mean. Are we in English class or math? What are we doing here? Could this have been written differently? Absolutely. If you use any of those key terms or bullets that I gave you, you'll be fine. I'll just quickly talk about Winnipeg. When it comes to the mean, a lower mean indicates overall colder temperatures. I'm just going to go temps there to help you out. That's so generous, eh? Standard deviation, yeah, go ahead. Standard deviation and range. A higher standard deviation and range indicate inconsistency which means that most days the temperatures will be further from the average.